Okay, so this is the algorithm for hierarchical clustering. If you want, you can simply write down in this format, okay? Because if the note is coming that write down a note on hierarchical clustering, how this clustering algorithm works, then even you can write down this one, but this is better like if you're writing the algorithm in this form, because this is very easier. Over here, I have taken a set of objects. Set of objects means these are representing your data points. Fine. So I'm taking the n data points. Sorry, 1 minute. N data points. N data points means you have been given n rows. Okay. So x1 is representing your one data point, xn is your nth data point. And suppose you are having a distance function in order to find out the distance between two clusters C1 and C2. Suppose this is your anything like complete linkage, or suppose that is your average linkage is there. Okay. So there is one function that will find out the distance between two clusters. So first of all, in hierarchical clustering, we assume that each data point is a different cluster. Okay, so there is one for loop for I changing from 1 to n. I'm assuming that xi is my one cluster. That means C1 cluster is being represented by your x1. C2 cluster is being represented by x2, and your Cn is being represented by xn data point. Okay, so each data point is being represented by different clusters. So if there are n data points, there would be n clusters. So we are just initializing each cluster to some value. Okay, so that value will be the data point. Fine. Next, I'm taking a set. In that set C, if there are n cluster, I'm storing all these clusters in one set. So C1, C2 to Cn. So all these are being stored in this set. Okay. So right now in this set, I'm having how many clusters are there? N clusters are there. So what was the basic idea of hierarchical clustering? That depending upon this distance function, we will start merging different clusters until we are getting one cluster. Okay. So while there is one while loop, while C dot size, what is C? C is the this set in which you are having n number of elements, n clusters are there. Okay, while the size of that is greater than 1. That means until you're getting one cluster, you need to do all these things. Okay. So while right now, what is the size? Size is n. So size is n. Suppose n is your 100. 100 is greater than 1. Yes. So what we will do? We will find out the minimum distance between among these clusters. Like you will find out what is the distance between C1 and C2, C1 and C3, so on, Cn1 and Cn. Next, what is the distance between C2 and C3 and all other clusters. Out of all these distances, you will find out what is the minimum distance. Okay, suppose it is saying that the minimum distance between two clusters, suppose that those clusters are C2 and C3. Okay, suppose the minimum distance is coming out to be between these two clusters. So what we will do? We will merge these two. Okay, so C minimum 1 and C minimum 2 is suppose the minimum distance for all Ci, Cj in C. Okay, so I'm assuming that the minimum distance is coming out to be between these two clusters. So I will merge them into one. So what we will do? We will actually remove C2 and C3 from this set. And instead of that, now I'm adding what I'm adding this as one cluster. Why? Because I have merged these two into one cluster. You can give any name, like here the name is like they are representing this as a small set. Suppose I'm saying this is your another set, something like suppose Cj or something. Okay, so here I'm saying C1, then Cj, so on, Cn is there. Okay, that means initially if there were n elements, now there would be n minus 1 elements. That means initially if there were 100 elements, 100 clusters, now there will be 99. Again, while loop would be run. Again, you will check the size. What is size? Again, it is greater than 1. Yes. Again, you will find out the distances among the different clusters, and you will choose two clusters having the minimum distance. Suppose again that is coming out to be something Cn minus 1 and Cn. So you will merge them into one. So number of clusters would be reduced. So this way we are doing until the size of that is 1. So when the size of this cluster, this set would become 1, that means when within this set you are having a one cluster only, suppose that cluster is being represented by something C1, you will come out of this while loop. Okay, so in this algorithm, it is not written that how to find out the optimum number of clusters, but if you want, you can write down one line over here that draw the dendrogram and find out the optimum number of clusters. Okay, so this algorithm, either you can write down or, oh, 1 minute, or this one. Okay, so this is again the same thing, like here it is written that initially suppose there are some data points D1 to Dn, or you can take X1 to Xn. So start with n number of clusters, each holds one object. That means each cluster is being represented by each object or each data point. Then compute the least distance pair of clusters. Okay, and update the distance matrix means like you can say this one. Okay, so you will start merging the clusters, and you have to repeat from step 2 to 4 will get repeated until there is one cluster left. Okay, so on next line you can write down that draw one dendrogram and find out the optimal number of clusters. So this much would be enough, like if you want to write down the algorithm for this hierarchical clustering. It's better if you write down in this format. Okay, so next, like advantages and disadvantages, I think I had written in the previous slide, what is the now advantage of hierarchical clustering as compared to k-means? What was the disadvantage of k-means? Main disadvantage of k-means was that we need to specify that how many clusters we have to take. Okay, so that was the first step. We need to specify that how many clusters I want to create. But in case of hierarchical clustering, we don't need to specify initially that how many clusters I have to take. Okay, that we can do by using a dendrogram. So that is the advantage of hierarchical clustering as compared to the k-means. But main disadvantage of hierarchical clustering is that its complexity is very high as compared to k-means. That is around like cubic complexity is there, something like you can say n raised to power cube, where n is the number of data points. So that is having the cubic complexity. Cubic means it's very high. So it is very actually slow as compared to the k-means and the other one, the density based algorithm. Okay, so that like you can write down that is the main advantage, this one, and the disadvantage of the hierarchical clustering. You can go through the previous slide. I have written the advantages and disadvantages of hierarchical. And even one more disadvantage is that even just like k-means, it can't handle outliers. If you are having noise and outliers in your data set, it can't handle that. Okay, for that we are having the next clustering algorithm, that is your Dbscan. I will be taking that thing. Okay, so it's fine. Any doubt in this? So next clustering algorithm that you have in your syllabus is density based. Okay, that is your density based clustering. Okay, suppose if I'm having a data set and if I'm plotting any scatter plot and you're getting a scatter plot just like this. Okay, so can you tell me that how many clusters you can see actually over here? Yes, Hagun. From this scatter plot, can you tell me how many clusters are there? There are 3 clusters. Okay, like we can see that there are 3 clusters. One is this one. Second cluster is being represented by this one, and the third cluster is being represented by this one. Okay, and you can see that they are having the different densities. Like this cluster is different from this one with low density area. Like over here, you can see that all the data points are centered around this center. Okay, so here you are having the high density of, I will tell you the meaning of density later on, but I think you know actually what is that meaning. Like density means you must have done in physics. Actually, in that case, it is represented by mass over volume. Okay, So you can see if you will draw a scatter plot, there is high density of data points. Then here also there is very high density of data points, and here also. But in between these cluster, you are having some areas of lower density. This area is of low density, and here also you are having low density area over here. Here you are having very low density of data points. Okay. So if you are having this distribution of data points, then k-means and both k-means and hierarchical clustering won't be able to give us the clusters properly. Okay, I'll show you the output. Suppose if you will apply k-means and hierarchical clustering, what is the output of that? Even you can see here, what is this? This is the noise. These are some outliers. You can see this data point that doesn't belong to this cluster, this one or this one. So this is actually the noise, or you can see in between also, there are some data points. These are your outliers, or these are the noise. Okay. So now if you will apply, suppose you are using any program to apply k-means and the hierarchical clustering. In case of k-means, this is the output of k-means clustering. So which clusters you are getting? Actually, there were 3 clusters, but according to k-means, they are 4 clusters. One cluster is actually being represented by this one. K-means is saying that this is your first cluster. The blue one is your second cluster. The green one is your third one. And it is also showing the fourth one. What is actually the fourth one? It was a noise that was present in your data set. So that noise is also being represented by a different cluster. So that noise, like you can see, is being represented by this purple color. And it is saying these are 3 clusters, but that is wrong. These are not your correct clusters. Okay. Similarly, if you are using the hierarchical clustering, this output you will be getting. So here also, even you can see it is saying this blue one is suppose your 1 cluster. This is your second one. Green one is your third, and noise is being represented by this cluster, that is your 4th one. So even this is not the correct way to cluster them. Okay, so both these k-means and hierarchical clustering won't be able to cluster your data set in the right way. Okay, so actually there were 3 clusters, but if you will use any density based clustering, you will be getting the output like this. Now this is right. You can see now 1 cluster was this middle one. Okay, so this is being represented by green color. Second is this one, and the third one is your this one, that is being represented by a red color. And you can see these purple data points. So that is not being represented by different cluster. Dbscan or density based clustering algorithm is saying they are only 3 clusters, and these are your outliers. This is the noise. Okay, so that noise is being represented by your purple color. So if you are having your data points of different densities, like they are separated by some low density areas, in that case we can't use k-means or your hierarchical clustering. That's why I said that both of these algorithms is having this advantage, that they are not able to handle the outliers. Here actually you can see that, right? So under density based clustering, this algorithm we will be using, that is called your Dbscan. So Dbscan is not just able to cluster the data points correctly, but it also perfectly detects outliers in your data set. You can see that from this picture, right? So what is the full form of this Dbscan algorithm? That is density based clustering of applications with noise. Okay, because it is actually based on clusters and noise. That's why this is called like applications with noise clustering method. Okay, so here I have written that also comes under the unsupervised learning method. And it is based on the idea that clusters are dense regions in data space separated by regions of low density of points. So this line is actually very important. So it is based on the idea that clusters are dense regions. Okay, so what's the meaning of the dense regions? Again, go to this. You are having this a cluster. So this cluster is having the dense region. This is also having very dense region, and they are being separated by low density regions, low density of points. Okay, so if you are having such type of data set, then we can use the Dbscan algorithm. Fine. I think this thing is cleared. What is the main purpose of using Dbscan? Why we are using this as compared to k-means and the hierarchical clustering? Both of these are having some disadvantage. That's why we are using it. Okay. Now it is working of this is very different one. So there are some terminology related to this. First, I will tell you about those things. If it is not clear, I will take one example, then everything would be clear. Okay. So there are some terminology related to this, like I need one value that is called epsilon, minimum points. What's the meaning of core point, border point, noise? First, I will tell you about all these things. Then I will reachability also. Then only I can start with my Dbscan algorithm. Okay, I'll take one example. Then I'll show you that how this is actually working. Okay. Yes. Any doubt in this? Is it okay? Shall I start with this now? What is this? One parameter or I need is over here is epsilon. Okay, what is epsilon over here? Suppose you have been given a different data set. So in Dbscan, the first thing is that what I will do, I will take one data point. I will draw, suppose you can assume I'm drawing a circle. I'm drawing a circle with radius epsilon. Okay. I'm taking one data point. That data point I'm assuming is a center. I'm assuming that as a center. Then I'm drawing one circle with radius, like I'm saying. What is the length of that radius? That is your epsilon. Okay, so why I'm drawing that radius? Now, if there are some other data points within this circle, suppose you are having some data points over here. So all these data points would be considered as a neighbor of this data point that is being represented by center of this circle. Is it cleared? What is this epsilon value? Okay. So like here again, I will go through these lines. It defines the neighborhood around a data point. Again, I'm saying, suppose you are having a data point. I'm drawing a circle by taking that data point as the center. And what is the size of the radius? The size of the radius is epsilon. If any other data point is coming within this circle, all those data points would be considered as neighbor of this. So actually, ultimately, whenever you want to make cluster, what is our main aim? Our main aim is that I want to find out that what are the different neighbors of this data point. Okay, like in case of hierarchical clustering, we were finding the distances by using the Euclidean distance. So actually over here, how I'm finding the neighbors of this data point? I'm taking one distance epsilon, I'm drawing a circle. So if any data point is coming within that, all those data points would be considered as the neighbors of this data point. So epsilon defines the neighborhood around a data point. If the distance between 2 points is lower or equal to epsilon, then they are considered as neighbor. Okay, obviously, if you are having a data point over here, then that means the distance between this and this is more than epsilon. That's why this data point is not coming within this circle. But if any other data point is the neighbor of this, that means the distance between these two is either equal to epsilon or lesser than that. Is it okay? Okay, so when we select the value of epsilon, there are actually again the methods, like I have written, there is one k distance graph, but I won't go through that. By using that, you can find out what is the optimal value of the epsilon that we can choose. Because if it is very small means if you will take a length of that radius as very small, then most of the data points would come outside this circle. Okay, so there would be very less points that are coming inside this. So most of them may be considered as outliers, or you can say noise. But if I will take very large value, suppose if I'm drawing a circle with very large value of epsilon, then the majority of data points would come within the same cluster. So that is also not a good thing. Okay, so the value of this should be selected by using, there is one like way to select the optimal value of that epsilon, that is by using the k-distance graph. Okay. Next is one more parameter, that is minimum points. Now, what is that? Okay, now actually each point can be over here. I have to tell that whether that is the core point, border point. There are three types of points: core point, border point, and the noise. Okay, for that I need that how many minimum number of neighbors should be there within this circle. Okay, suppose if again I'm drawing a circle with epsilon radius, then how many data points should come, minimum number of data points that should be there within this circle. That is called the minimum points. Okay, suppose if I'm saying the minimum point should be 5, including this data point. Suppose over here I'm saying 1, 2, 3, 4, 5. 1 minute. There are actually 5 data points within this circle. So min points is 5. If min points is 5, then I will tell you what this data point is called. And if you're drawing a circle, but within that, if you have specified that the minimum number of points should be 5, but here you are getting just 3, then this data point is actually called the border point. That I will tell you later on. So what is minimum number of points? Minimum number of neighbors or data points within this circle, like you can see. Now, if larger the data set, larger value of minimum points should be chosen. Okay. Usually, what is the value of minimum points that we choose? That should be greater than equal to d plus 1, where d is the number of dimensions. Dimensions means number of features in your data set. Like if you are having 4 features, then minimum number of points that you should select is greater than equal to 5. Okay, so this thing would be cleared, like what is the meaning of this minimum points. So minimum value of minimum point must be chosen at least 3. It should be at least 3, but actually it should be greater than equal to 3, like 4, 5, 6, 7 we should select. Okay, so I think this is clear. What's the meaning of epsilon and minimum points? This is very important. If you have any doubt, you can ask me what's the meaning of this. Yes. Is it cleared? Anyone, please write down in chat box. Is it cleared? Yes, Deepak. Gurpreet Singh. Hamid Ali. Okay. Okay, now in this algorithm, we are using one word, that is the density. Okay, so you are already familiar with this density, but with respect to this algorithm, now what's the meaning of density? Here it is written number of points within a specified radius along with the minimum number of points. Okay, like suppose when you are drawing a circle with epsilon radius, how many data points are coming within this? Okay, that is representing the density of this, density of like this circle, like you can see, number of points within specified radius. Okay, now how many data points are there within this? Suppose I'm taking the radius of this is 4. It is 1, 2, 3, 4, 5, 6, 7, and 8. So you can see the density of this is 8, like. Okay, so density is representing this thing. Is it cleared? if I'm drawing one more circle in which there are only 3 data points, so you can say density of this is very less because there are just 3 data points within this epsilon radius. So density is very less here, density is high, right? Now, there are other things also that I need in this algorithm, that each data point that I have to take in this algorithm, it can be of these 3 types. One is core point, border point, and the noise. What is the core point now? Now, suppose I'm saying the value of my epsilon is 4, and the minimum number of points that I want to take within a circle is suppose 5. Okay. Now, suppose one data point is given to me. I will draw a circle with epsilon with radius 4. And suppose within that, there are some more data points within this circle are coming. Okay. Now just count the number of data points. There can be some data points at the border also, at the border of this circle. Now, including this center, 1, 2, 3, 4, 5, and 6 are there. Okay. What I wanted that minimum number of points should be 5. I'm saying in this algorithm, if I'm drawing a circle, but here I'm getting more than 5. That means if you're getting 5 or more than 5 data points when you're drawing a circle, then this data point is called a core point. Okay. So what is a core point? A point is core point if it has at least specified number of minimum points within epsilon. That means if it is having minimum number of 5 neighbors. And what's the meaning of the neighbor? If they are at a distance of epsilon or lesser than that. If any data point is at a distance greater than epsilon, then that is not considered as a neighbor. Is it okay? So all these points are, if they are at the interior of a cluster, or you can say at the interior of this circle, then that point is considered as a core point. Fine. And what is a border point? A point which has fewer than minimum points within epsilon. That is one condition. Suppose now I'm taking one more point over here. You take this point only, this point. Now, using this as center, again, I'm drawing a circle. Now count the number of points within this. There are 1, 2, 3, just 3 points. But what is the minimum number of points I wanted? That was 5. So it is having lesser than 5 neighbors. If it is having lesser than 5 neighbors, then it is called border point. But there is one more condition for this to be a better border point. What is that? It should be the neighbor of any core point. Like here, I have selected this as the center, but this was the neighbor of this core point. Okay, so if this point is the neighbor of my core point, but this is not a core point, that means it contains lesser than minimum number of neighbors, then that is called a border point. I'll take one more example, then it would be clear. First, I will take these two. What's the meaning of these two? Take this one. Suppose I'm considering in my example that minimum number of points should be 7 for a point to be a core point. Okay. Now take this data point A. I'll draw a circle with radius epsilon. Suppose the value of epsilon is given to be something, suppose 5. Okay, so I'm drawing one circle, this circle now. Count the number of points within that, including this one, 1, 2, 3, 4, 5, 6, and there is one more 7. Okay, so what was the minimum number of points that we had set? That was 7 only. So within this circle, actually 7 points are coming. So I can say this is my core point. A is the core point. Fine. Okay, now I'm taking this point as my center. Again, I'm drawing a circle, now this circle, with radius epsilon. Now count the number of points within that. How many points are coming, including this? 1, 2, 3, and you can say this one also, 4. Okay, 4. but it is lesser than minimum number of points because the minimum number of points that we had set was 7. So this is not the core point. If this is not the core point, I need to set whether this is a border point or not. Okay, now it will be a border point if it is the neighbor of any other core point. Yes, it was a neighbor of this core point. B was the neighbor of A. So I can say this is the border point now. Okay, now take C data point. Again, draw one circle with radius epsilon. Okay, now again count the number of points. Again, the number of points within the circle are 1, 2, and 3. Okay, so it is not satisfying the minimum number of points condition, but just tell me, only 1 minute is remaining.
4 points.
Is it, Himanish, 1 minute. Is it in the neighbor of any another core point? Yes, Ashley, is it in the,
No, ma'am.
no, this is not the neighbor of any another core point. So this is called the noise. Noise means this would be considered as an outlier. Okay. So this thing should be clear. Then next time I will take one example and I will show you the working of this Dbscan. Yes, Himanish.